Ants are everywhere, yet almost never noticed. They move beneath our feet, inside walls, across forests, deserts, jungles, and cities. They were here long before humans built civilizations, and they will likely remain long after those civilizations disappear. Ants are not background life. They are infrastructure. From a biological perspective, ants are among the most successful organisms ever to exist on Earth. They belong to the family Formicidae and evolved over 100 million years ago during the age of dinosaurs. While massive reptiles vanished and climates shifted dramatically, ants refined a system that favored cooperation over individuality. That decision changed everything. An individual ant is fragile, small, short-lived, limited in intelligence, but an ant colony is something entirely different. It is a superorganism, a distributed biological machine composed of thousands or millions of bodies acting as one. This is not metaphor, it is literal. No single ant understands the colony. No ant issues commands, and yet colonies build complex nests, regulate temperature, allocate labor, wage wars, farm crops, herd livestock, and adapt to environmental change with remarkable efficiency. Ants achieve this without language, without centralized brains, and without conscious planning. They operate on rules. Ant evolution began with wasp-like ancestors that gradually adapted to life on the ground. Over time, they lost wings in worker castes, developed strong mandibles, chemical communication systems, and a rigid division of labor. Queens reproduce, workers build and forage, soldiers defend. Each caste is biologically distinct. Some ants are born with massive jaws for combat, others with elongated bodies for carrying, others with chemical glands optimized for signaling. This specialization allows colonies to outperform solitary organisms in almost every ecological category. Communication is the foundation. Ants rely heavily on pheromones, chemical signals released into the environment. These signals encode information about food, danger, territory, hierarchy, and reproduction. A single drop of pheromone can coordinate thousands of ants within seconds. When an ant finds food, it does not remember the path in a human sense. It lays a chemical trail. Other ants follow. The strongest path becomes reinforced. Inefficient routes fade. This is collective optimization. Ants solve problems through emergence. Traffic jams dissolve. Supply lines adjust. Foraging patterns shift dynamically based on success rates. No ant knows the plan, yet the plan works. Some ant species practice agriculture. Leafcutter ants harvest vegetation not to eat directly, but to cultivate fungus. This fungus is their primary food source. Colonies manage fungal gardens with precision, removing contaminants, adjusting humidity, and selecting optimal plant material. This system predates human agriculture by millions of years. Other ants practice animal husbandry. They herd aphids, protect them from predators, and milk them for honeydew. In exchange, aphids gain safety and mobility. This is mutualism refined to efficiency. Ants also wage war. Territorial conflicts between colonies can involve tens of thousands of individuals. Some species conduct organized raids, enslave workers from rival colonies, or eliminate competitors entirely. Casualties are expected. Ant warfare is not emotional. It is mathematical. If losses lead to long-term gain, the colony proceeds. Ecologically, ants are engineers. They aerate soil, improve nutrient cycling, disperse seeds, regulate insect populations, and influence plant diversity. In many ecosystems, removing ants causes collapse. Their biomass is staggering. Scientists estimate that the total mass of ants on Earth rivals that of all humans combined. In some tropical regions, ants make up more than a quarter of all animal biomass. They dominate quietly. Ants adapt rapidly. Urban ants learn traffic patterns. Desert ants navigate using polarized sunlight. Some ants tolerate extreme heat. Others survive freezing. Some live underground. Others build towering mounds. They exploit niches humans ignore. Ant lifespans are short, but colonies can persist for decades. Queens may live 20 to 30 years, producing millions of offspring. The colony becomes a living archive of experience, adapting across generations. Humans often view ants as pests. This is misunderstanding. Ants do not invade homes out of malice. They respond to resources. Food left exposed becomes a signal. Structures provide shelter. Ants exploit opportunity the same way humans do. The difference is scale. Ants do not destroy ecosystems at planetary levels. Humans do. In studies of resilience, ants outperform nearly every animal group. They recover from population loss quickly. They recolonize disturbed land. They adapt behavior faster than many vertebrates. If environmental collapse accelerates, ants will not panic. They will reorganize. Ants teach an uncomfortable lesson. Intelligence does not require individuality. Power does not require size. Success does not require dominance through force. It requires coordination. They show us that cooperation, when enforced by structure rather than emotion, can outperform strength, speed, and intellect. Ants do not aspire, they do not dream, they do not question, they function, and through that function, they rule.